Beyond the familiar planets of our solar system lies a frozen frontier, a vast, mysterious region where the ancient remnants of our solar system's birth remain perfectly preserved. This is the Kuiper Belt, a ring of icy debris that stretches from beyond Neptune's orbit and holds the key to understanding the early days of our cosmic neighborhood. Home to dwarf planets like Pluto, Haumea, and Eris, along with countless icy objects, the Kuiper Belt is not just a distant graveyard of ancient debris. It is a time capsule that holds clues about the origins of our solar system and the building blocks of life itself. As we journey to the outermost reaches of the solar system, we uncover secrets that challenge our understanding of the universe, from bizarre worlds to the tantalizing possibility of undiscovered planets lurking in the deep. Join us as we explore the hidden wonders of the Kuiper Belt and the tantalizing mysteries it continues to reveal. The frozen frontier of the solar system. In the dark, frigid void beyond Neptune lies a vast and mysterious region, where the ancient remnants of our solar system's birth drift silently through the darkness, perfectly preserved by the deep freeze of space. To reach this shadowy expanse from Earth, we must travel past the rocky planets, flying by Mars and then beyond the swirling storms of Jupiter and Saturn. Farther still, out beyond the blue giants Uranus and Neptune, we finally reach our destination. Welcome to the Kuiper Belt, a vast ring of icy debris encircling our solar system like a frozen halo. This isn't just a collection of distant rocks. It's a time capsule from 4.6 billion years ago, holding the untouched building blocks of our cosmic neighborhood. It is home to several dwarf planets and mysterious objects that have left many astronomers scratching their heads. Before we knew for sure that the Kuiper Belt was real, astronomers suspected that something existed beyond Neptune. For decades, everyone's favorite dwarf planet, Pluto, was thought to be an isolated object in the outer solar system. But something didn't add up. Its small size and unusual orbit suggested that Pluto wasn't alone, that maybe it was merely one of a number of yet-to-be-discovered distant objects. In 1951, astronomer Gerard Kuiper predicted the existence of a belt of icy objects just beyond the orbit of Neptune. But without telescopes powerful enough to detect these objects, the idea remained theoretical for decades. That changed in 1992, when astronomers David Jewitt and Jane Liu discovered the first confirmed Kuiper Belt object, known as 1992 QB1. Pluto and its moon Charon were both discovered before 1992 QB1, Pluto in 1930 and Charon in 1978. But these objects were only confirmed as Kuiper Belt objects, KBOS, after the discovery of 1992 QB1. Since then, thousands of KBOS have been identified populating this distant region beyond Neptune. To grasp the true scale and position of the Kuiper Belt, let's imagine we're traveling in a spaceship, starting from the Sun and moving out toward the outer edge of our solar system. And as we move along our journey, let's compare the Kuiper Belt to both the more well-known asteroid belt and the less well-known Oort cloud. Starting near the Sun, we zip past the rocky planets, Mercury, Venus, Earth, and Mars. Between Mars and Jupiter, we see the asteroid belt, made up of the leftover materials from when our planets formed. A thin, spread-out ring of rocky debris. The asteroid belt is about 2.2 to 3.2 astronomical units, AU, away from the Sun and about 1 AU wide. As a reminder, 1 AU is the distance from the Sun to Earth. Most of the known asteroids reside in this part of our solar system, ranging in size from the largest asteroid, Vesta, at 525 kilometers wide, almost the distance from London to Belfast, to the smallest objects, some of which are just tens of kilometers across. However, despite residing in such a large space, the total mass of all the asteroids in the asteroid belt combined is only about 3% of the Moon's mass. Beyond the asteroid belt, we encounter the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune, colossal worlds that dominate the outer solar system. Finally, as we pass Neptune's orbit at 30 astronomical units, we reach our destination, an even more remote, icy frontier, the Kuiper Belt. This vast expanse stretches from 30 to 50 astronomical units and is home to a range of intriguing objects, from frozen relics of the early solar system to dwarf planets like Pluto, Haumea, Eris, and Makemake, as well as countless smaller objects. Like the asteroid belt, the Kuiper belt contains ancient debris from our early solar system. In fact, Kuiper belt objects are considered some of the oldest surviving pieces of our solar nebula, the original cloud of gas and dust that formed the planets. At one point in the distant past, these stray pieces might have come together to form yet another planetary body. However, Neptune's gravity prevented the icy objects from coalescing, never allowing them to form something new. Unlike the asteroid belt, which is primarily made of rocky material, the Kuiper belt consists mostly of frozen methane, ammonia, and water ice, forming a frozen, thick, donut-shaped ring of debris. The Kuiper belt contains hundreds of thousands of large icy bodies, bigger than 100 kilometers across, and more than 1 trillion comets, not to mention smaller debris and dust. And the average distance between objects is so large, it's hard to imagine. Each of those objects is, on average, 10 million kilometers apart. Here, in the dim outer reaches of our solar system, these icy bodies drift in near silence, preserving vital clues about the origins of planets and comets. But it doesn't end there. That was just the main region of the Kuiper belt. Overlapping the outer edge is another area called the scattered disk, which continues out to nearly 1,000 astronomical units, with some KBOs on orbits that reach even farther. So while the asteroid belt and Kuiper belt share some similarities, the Kuiper belt is vastly more expansive than its rocky counterpart. And while we may have reached the end of the Kuiper belt, there's still another massive structure that surrounds every other object and belt I've mentioned so far. In a recent video, I talked about the Oort cloud, the colossal structure of orbiting icy debris that encircles our entire solar system. It's so jaw-droppingly far away that even our most powerful telescopes can't catch a glimpse. So how do these two structures, the Oort cloud and the Kuiper belt, differ? For one, the Kuiper belt is thousands of times closer to the Sun than the center of the Oort cloud, which is theorized to stretch from around 2,000 to 100,000 astronomical units. Another major difference is that the Kuiper belt is donut-shaped, while the Oort cloud is spherical, like a gigantic bubble of swarming debris. But something these structures do have in common is that they are both sources of comets. The Oort cloud is the source of many long-period comets, while the Kuiper belt is where some short-period comets are born. While the Kuiper belt today is one of the most massive structures in our solar system, it's just a small fraction of what it once was. Originally, it probably contained 7 to 10 times the mass of Earth, but the shifting orbits of the giant planets caused most of that to be lost to space. What remains is no more than about 10% of Earth's mass. Not only that, but the Kuiper belt today continues to slowly erode away. As objects occasionally collide and break apart, smaller fragments are left in their wake, and some of the resulting dust is blown out of the solar system by the solar wind. Sometimes these collisions, or Neptune's gravity, will cause KBOs to head on a new path toward the Sun, creating short-period comets, which have orbits of less than 200 years. Over time, the Sun's radiation causes comets to shed material, producing the spectacular tails we see from Earth. Several famous comets originate from the Kuiper belt, or its scattered disk, including Halley's Comet, with an average orbital period of 76 Earth years, and Comet Shoemaker-Levy 9, which broke apart and smashed into Jupiter in 1994, the first ever observed collision of two solar system bodies. As we'll see in the next part, the Kuiper belt isn't just a graveyard of ancient ice, it's also home to some of the strangest worlds ever discovered, including Pluto, Arakoth, and other bizarre objects that defy expectations. The strangest worlds in the Kuiper belt. While most of what we know about the Kuiper belt comes from ground-based telescopes and the Hubble Space Telescope, NASA's New Horizons is the only spacecraft to have actually been there. It performed a flyby of the dwarf planet Pluto in 2015 and later visited the Kuiper belt object Arakoth in 2019. These encounters revealed worlds stranger than anyone had imagined. Let's start with Pluto, the most famous resident of the Kuiper belt. For decades, Pluto was just a blurry dot in telescopes, a mysterious world at the edge of the known solar system. But when New Horizons flew by in 2015, it transformed Pluto from a pixelated mystery into a living, dynamic world with glaciers, mountains, and even a hazy atmosphere. The most striking feature? Pluto's heart. Officially named Tombaugh Regio, after Pluto's discoverer, Clyde Tombaugh. This bright, heart-shaped region is actually a massive glacier made of nitrogen ice. The western lobe, called Sputnik Planitia, is a sprawling basin 1,000 kilometers wide and 4 kilometers deep, the largest known glacier in the solar system. But how did this heart form? For years, scientists debated whether it was the result of an ancient impact or something even stranger, like a hidden subsurface ocean. A recent study led by astrophysicist Harry Ballantyne suggests the heart shape was created by a slow, oblique impact. Imagine a cosmic snowball hitting Pluto at a shallow angle, splattering nitrogen ice across its surface like a water balloon smashing on pavement. Pluto's geology doesn't stop there. The dwarf planet has ice mountains as tall as the Rockies made of water ice, which is rock hard at Pluto's frigid temperatures. It even has cryovolcanoes, volcanoes that spew slushy ice instead of lava. One of these, Right Mons, stands 4 kilometers high and could still be active. Then there's Pluto's hazy atmosphere, a thin blue layer of nitrogen, methane, and carbon monoxide that extends 1,600 kilometers into space. Sunlight breaks down methane high in the atmosphere, creating tholins, organic molecules that rain down as red snow, giving Pluto its rusty hue. But Pluto isn't alone. It has 5 moons, the largest being Charon, a world so big that Pluto and Charon orbit a shared center of gravity, making them more like a binary system than a planet and moon. New Horizons images of Charon revealed a shockingly active world. Its surface is scarred by a gigantic equatorial canyon, evidence of a past underground ocean that froze and cracked the moon's crust. Some regions, like Vulcan Planum, are smooth plains of frozen lava, while others are littered with mysterious red spots, possibly organic material leaked from Pluto's atmosphere. But Pluto and Charon were just the beginning. In 2019, New Horizons made history again by flying past Arrokoth, a bizarre Kuiper belt object 4 billion miles from Earth. Arrokoth, whose name means sky in the Powhatan Algonquian language, is unlike anything else we've seen. It's a contact binary. 2 distinct lobes fused together like a cosmic snowman. The larger lobe is pancake flat, while the smaller one is more rounded, giving Arrokoth a shape that defies expectations. But Arrokoth's strangeness isn't just skin deep. Its surface is smooth, with no impact craters or fractures, suggesting it formed gently from 2 objects slowly merging in the early solar system. This was a major clue in solving a decades-old debate. How do planets form? For years, astronomers argued over 2 theories. 1. Hierarchical accretion, small objects smashed together violently, building larger bodies. 2. Local cloud collapse, nearby objects gently stick together due to gravity. Arrokoth's pristine, unbroken shape proves the second theory is correct. It formed in a slow, delicate dance, not a violent collision. As New Horizons lead scientist Alan Stern put it, we've decisively solved a multi-decade debate about how planetesimals form. But Arrokoth isn't the only weird KBO. Let's talk about Haumea, a fast-spinning, egg-shaped dwarf planet with rings and 2 moons. Haumea rotates so quickly, once every 3.9 hours, that it's stretched into an ellipsoid, like a cosmic football. Scientists think this spin comes from an ancient collision that also created its moons, Higiaka and Namaka, and possibly even its mysterious ring system. Then there's Makemake, a reddish, methane-covered world with no atmosphere, unlike Pluto. But in 2016, astronomers discovered a tiny moon orbiting Makemake, MK2, a dark, charcoal-black moon that's 1,300 times fainter than its parent body. And we can't forget Eris, the most massive dwarf planet in the Kuiper belt, 27% heavier than Pluto. Eris is so far away, 96 astronomical units, that its surface temperature hovers near negative 405 degrees Fahrenheit, negative 243 degrees Celsius. It has a tiny moon, dysnomia, and a surface so reflective it's one of the brightest objects in the solar system. But the strangest thing about Eris? it shouldn't exist. Most Kuiper belt objects have elliptical orbits, but Eris's orbit is highly tilted, at a 44-degree angle to the solar system's plane. This suggests Eris was flung outward by a gravitational encounter, possibly with Neptune, in the early solar system. These bizarre worlds are just the tip of the iceberg. The Kuiper belt is full of mysteries waiting to be solved. Kuiper, a dwarf planet with a ring system that defies orbital physics. Gong, a reddish world with water ice and a possible atmosphere. Sedna, an object so far out, 900 astronomical units, it might belong to the inner Oort cloud. And the biggest question of all, are there more dwarf planets or even a hidden Planet X lurking in the Kuiper belt? The hidden secrets of the Kuiper belt. And what lies beyond the Kuiper belt is more than just a graveyard of ancient ice. It's a cosmic detective story holding clues to some of the biggest mysteries in our solar system. From the possible existence of a hidden ninth planet to the role these icy worlds played in delivering water and even life to Earth, the deeper we look, the more astonishing the discoveries become. The hunt for Planet 9. Beyond the known Kuiper belt lies one of astronomy's greatest unsolved mysteries. Is there a massive, undiscovered planet lurking in the outer solar system? For decades, astronomers have debated the existence of Planet X, a hypothetical world far beyond Neptune. But in 2016, new evidence emerged. Researchers studying the orbits of extreme Kuiper belt objects, KBOs, noticed something bizarre. Several of them had orbits that clustered together, tilted at similar angles, as if something massive was tugging on them. The math suggested this unseen planet, now called Planet 9, could be 5 to 10 times the mass of Earth, orbiting about 500 astronomical units from the Sun. That's 15 times farther than Neptune. If it exists, it would take 10,000 to 20,000 years to complete a single orbit. But why haven't we found it yet? It's incredibly far away. At that distance, sunlight is almost non-existent, making it nearly invisible. Its orbit is highly elliptical. Unlike the other planets, Planet 9, if real, would follow a stretched, looping path. We've only searched a tiny fraction of the sky. Telescopes like Subaru and Vera C. Rubin Observatory are scanning the outer solar system, but it's like finding a needle in a cosmic haystack. Some scientists think Planet 9 could be a rogue planet, captured by the sun's gravity long ago. Others suggest it might be a primordial black hole, though that's far less likely. Until we spot it, the mystery remains. The Kuiper belt's role in the origins of life. One of the most surprising discoveries about the Kuiper belt is that these frozen worlds might have played a critical role in bringing water and the ingredients for life to Earth. How? Comets as cosmic delivery trucks. Many short-period comets originate in the Kuiper belt. When they collide with planets, they deliver water ice and organic molecules. Scientists studying comets like Halley's and 67P/Churyumov-Gerasimenko have found amino acids, the building blocks of proteins, embedded in their ice. If comets bombarded early Earth, they could have seeded our planet with water and prebiotic chemistry, setting the stage for life. Pluto's hidden ocean. New Horizons found evidence that Pluto might still have a liquid ocean beneath its icy crust. If so, other large KBOs like Eris and Makemake could too. Where there's liquid water, there's potential for extremophile life, organisms that thrive in extreme cold and darkness. Arakoth's organic molecules. The reddish color of Arakoth comes from tholins, complex organic compounds created when methane is exposed to cosmic radiation. These same molecules may have rained down on early Earth, providing raw materials for life. The future of Kuiper Belt exploration New Horizons was just the beginning. The next generation of missions could revolutionize our understanding of the outer solar system. Interstellar Probe 2030s. NASA is studying a mission that would fly 1,000 astronomical units from the Sun, passing through the Kuiper Belt and into interstellar space. It could finally map the outer edges of the Kuiper Belt and search for Planet 9. James Webb Space Telescope, JWST. JWST is already studying KBOs in infrared, analyzing their composition, atmospheres, and possible plumes. Oh, could it detect cryovolcanic activity on Pluto or Eris? Pluto Orbiter mission scientists are pushing for a dedicated Pluto orbiter to study its geology, atmosphere, and possible subsurface ocean in detail. Oh, imagine a lander touching down on Sputnik Planitia, drilling into the ice. The biggest question, are we alone? The Kuiper Belt may seem like a frozen wasteland, but it's also a time capsule from the birth of the solar system. If life exists elsewhere in our cosmic neighborhood, the Kuiper Belt, with its organic-rich comets, hidden oceans, and dwarf planets, might be the best place to look. As technology advances, we're on the verge of unlocking its secrets. Who knows what we'll find next? A new dwarf planet? Proof of Planet 9? Or even clues to how life began? One thing's for sure, the Kuiper Belt is far from dead. It's a living laboratory waiting to reveal the next great discovery in planetary science. From Pluto's beating icy heart to the snowman-shaped Arakoth, from the mysterious Planet 9 to the origins of life itself, the Kuiper Belt is one of the most fascinating and least explored regions of our solar system. What do you think lies out there? A hidden world? Ancient microbes frozen in ice? Let me know in the comments, and don't forget to like, subscribe, and hit the notification bell so you don't miss our next deep dive into the cosmos. Thanks for watching, and keep looking up. Blast off.